In this construct, we oftentimes refer to as a lake house, which brings together the best of a data lake plus the best of a data warehouse that allows end users, through structured query language or SQL, to access data where it resides, whether it's been loaded into Amazon Redshift or simply a data file sitting on Amazon S3. To the consumer of that data, they don't really know or care where that data resides. They simply know they have access to all their data. And not having to think about what data is in my Hadoop cluster, what's in my data warehouse, but providing a scalable infrastructure to query both. And so Lakehouse really encompasses the ability to get access to all of your data, whether it's loaded into Redshift or not. And here's just a great example of a customer that's actually implementing the Lakehouse in Cloud Data Warehouse on AWS. And so Nielsen moved from an on-premise IBM Netezza system, not just to leveraging Amazon Redshift, although it's a core component, but also the richness of Amazon S3 to land event data, to be able to integrate other services like Amazon Athena to be able to provide that serverless access for data exploration. And so thinking about all of these functions they had to do previously in their on-premise data warehouse appliance, but really thinking about what's the use case, what's the right workload, how do I unlock the value of the data is really core to what Nielsen was able to achieve. There's lots more details on our website to go into Nielsen's use case in detail. Now, what are some benefits that Amazon Redshift can deliver on the Lakehouse architecture, as well as being able to deliver better insights to data? Well, first, Redshift integrates the data lake and data warehouse around this concept called Lakehouse. And so with features like Redshift Spectrum, you can seamlessly access all of your data on S3, as well as through Query Federation, reach out to Postgres databases, whether it's Aurora Postgres or RDS Postgres, to integrate that data source without having to move the data. And so the idea of breaking down data silos, of integrating the data lake and data warehouse is a core value that Redshift can deliver. But also we think that in doing so, you don't have to compromise on performance. And so leveraging the best of AWS engineering in terms of delivering fast, consistent performance. And we've done a number of third-party benchmarks, and as well as your own use cases that can help highlight the fast access to data that Redshift can provide. But then also thinking about the value and the cost. And one of the tenets of moving to the cloud is being able to not just deliver innovation, but of course doing so at a radically different price point, particularly compared to on-premise data warehouses. And so being able to deliver up to 75% savings off on-demand rates by looking at the different mechanisms to save with Amazon Redshift is a core to getting the true value. But also thinking about the scale. And so Redshift is really designed not just for gigabytes or terabytes of data, but being able to expand out to exabytes of data. And while you might not have hundreds of terabytes, petabytes, or exabytes of data today, if you think about the expanding growth of data, almost certainly you will. And so thinking about how I can have a scalable analytic framework that can start off with my use case today, but be able to expand to exabytes of data becomes a core value proposition that Redshift can deliver. And also thinking about being able to store your most secure data in Redshift. And so there's a flexible set of encryption techniques as well as access control that's been validated by third-party certifications such as HIPAA or FedRAMP to be able to give you the assurance that you can store your most sensitive data in Redshift at no additional cost. And so one of the valid benefits of Redshift is there's no secure edition or enterprise edition of Redshift. You simply are able to leverage Amazon Redshift and all of its features given the security compliance and encryption needs or access control needs that your organization requires. And also one of the areas that we'll talk about is really around ease of use or ease of management. Particularly if you've been using Redshift for a while or if you're new to it, understanding you have this powerful capability without the need for dedicated database administrators or large technical staffs. And we put a lot of focus on how you can get started easily with Amazon Redshift to be able to deliver the best value. And here's a great customer quote of one of our large telco provider in Japan, NTT Docomo, and the benefits they found by migrating from their on-premise data warehouse to Amazon Redshift in being able to deliver that fast performance. They call out being 10 times faster than their on-premise data warehouse, the dramatically lower cost, but then increasing the flexibility for their analysts to get access to more than just the traditional data sources, but really building upon this lakehouse concept that breaks down the data lake and data warehouse into a single set of analytic capability that provides insights to all of NC Docomo's data. Beyond NC Docomo, and our quick case study with Nielsen, tens of thousands of users and customers are getting value from Amazon Redshift today. Here's a slight logo slide of a few case studies and use cases that are available in more detail, but you'll see across many different geographies, different industries, public sector, private sector, are all seeing the value of moving to a lakehouse architecture centered with Amazon Redshift. Having gone through a little bit of the overview, let's talk a little bit about the architecture and concepts that underlie a cloud data warehouse built with Amazon Redshift. First, it's easy to create and get started. You simply can go into the console. We've done a lot of work in terms of simplifying the selections and being prescriptive in terms of what we think the right architecture will be to get started. And so you can easily provision a Redshift cluster, start creating tables, loading data, as well as integrating with your ETL service. So particularly where we're migrating from on-premise systems, customers oftentimes will already have transformation scripts written in a third-party tool such as Informatica. And so knowing that we have this large ecosystem of third-party certifications to be able to leverage your data transformation or visualization tools can be a big benefit when migrating from on-premise. That allows you to focus on getting the value from your data warehouse first. And then perhaps as you get more experience, you can optimize your ingest workflow to leverage other alternatives such as Spark to be able to ingest data. But knowing that you can quickly and easily connect your ETL tool and BI tool and start seeing the value from Redshift very quickly in a matter of minutes, for instance. Redshift is built upon a scalable, massively parallel processing framework that then extends to all of your data leveraging a feature through Spectrum. So some of the terminology that you'll hear about as you start provisioning and working with Redshift starts off with the leader node. And think of the leader node as simply a lightweight process to which connects to your BI tools that is then able to then access the power of all the compute nodes behind the scenes. And so the leader node is just the way to connect and provides that interface within your VPC to be able to access the power of all the compute nodes. The compute nodes themselves contain all of the columnar database structures within a Redshift cluster. And as this becomes interesting when you think about the scale of data, and so with features like concurrency scaling, you can automatically shrink and grow your compute nodes. Or for cost saving perspective, you can provision a set number of compute nodes to get started and leverage things like reserved instances to get the best value from more known workloads, but then backing up with features like concurrency scaling as my users peak and ebb throughout the day. But then knowing that all of this is then backed by Amazon S3, and so we're able to then do things like automatic backups and be able to remove some of the complexity, knowing that the data is not just stored within the Redshift cluster, but also leveraging S3 to have that persistent state of the data as well. We then evolved this architecture of Amazon Redshift with a feature called Spectrum that includes a serverless compute layer that's able to extend the power of the Redshift compute nodes to all of your data on Amazon S3. So what happens is when I query a data, in the optimizer led by the leader node in Redshift can evaluate where that data is located. If it's in one of the local compute nodes, I'll be able to return the query as in a classic Redshift architecture. What Spectrum then delivers is the data is external to Redshift. If it's on Amazon S3, if it's a nested JSON file on S3, for instance, the leader node will then look at that query and then dispatch that query to the serverless Spectrum layer to actually execute in Amazon S3. And the benefit here is I don't have to pre-provision the hardware for Spectrum. It simply determines based upon the query how much compute processing is needed and then able to query the data on S3 directly. And so to the end user, they simply see a set of schema, tables, columns, rows. Some of that data might be local to Redshift. Some of that data might be unstructured data or JSON data, Parquet data on S3. But to the consumer of the data, they don't have to know. They simply see schemas, tables, columns, and are able to issue SQL queries regardless if the data is local to Redshift or not. And so you can imagine the use case where I'm landing event data and I need that real-time access. I can't afford to load it into Redshift native table formats. I can simply leverage a Spectrum feature to query it immediately on S3. Redshift has also continued to evolve. So we started off with that notion of the compute nodes with data being local. We added a feature called Spectrum that allows you to then query the data on S3. The next evolution of Redshift comes into play with our launch of the RA3 instance type at reInvent of 2019. What this did was be able to deliver not just the power of Amazon Redshift query processing, but also now delivers upon the separation of compute and storage. It introduces a concept called Redshift Managed Storage. So now data does not have to be local to the compute node to be able to access it. We simply think about the local disk of the Redshift cluster as a performance or caching layer. The rest of the data can seamlessly be stored on Amazon S3. And so by doing so, you simply have to think about how I scale my data warehouse based upon the compute that's required and not the storage. And being able to leverage the Redshift Managed Storage allows you to take the best advantage of a data warehouse in terms of getting that native file format, that fast, consistent performance, but now not having to worry about how much data I store or having to unload data. And so you can still leverage the ability of Spectrum to reach out to native data formats on S3, but being able to now take the best of separating compute and storage with the RA3 instance type, and really the cost benefit of Redshift Managed Storage has really been the next evolution of the Redshift architecture for cloud data warehouses. Now, a couple of terms we've been talking about, just to kind of circle back, Redshift itself is a columnar data warehouse, meaning that fundamentally it organizes data into columns. And the reason for this is that from an analytic query perspective, most analytic queries look upon columns of data and does operations like counts or sums, and so show me the sales for a particular region across a period of time. And columnar databases are particularly have an advantage in these type of analytic queries that are underpinned by the Redshift Managed Storage and the columnar nature. And so we can also not just get fast, consistent performance, but columnar databases are particularly effective at high compression ratios. And so when I load data, in an example of getting started, when I actually start loading data into Redshift, we automatically look at the best compression encoding for that data type and then apply that automatically. Most customers can see anywhere from 3 to 4x compression from a raw format by simply leveraging the native compression available in Redshift itself, built upon the columnar data types. There's also, talking a little bit more about the compression, not just can I leverage the automatic compression, but if I'm a more advanced user, I really want to get the best resources or best query performance from the resources available, I can use my own specific and column encodings when I'm loading the data. Now, that does require a little bit of advanced work, and so you don't have to. You can simply leverage the automatic compression, which most customers do. And then in the Redshift console, in the advisor, you'll be able to see a recommendation if we think there's a better compression encoding, along with the SQL in order to affect that change. But knowing that Redshift, can actually compress data. So if I have, tens of terabytes, hundreds of terabytes of data, and I'm thinking about how much data do I need to store in Redshift, taking into account the compression that's available can be an important factor when sizing as well. So having gone through some of the basics, let's talk about what's new with Amazon Redshift. And one of the things, Redshift was launched in 2013, so it's been on the market for about 7 years. And we've been constantly taking customer feedback in terms of how we can make things easier, how we can make queries faster, how we can, alleviate some of the burden of administrating the Redshift cluster. So today, Redshift is a dramatically different database than we launched 7 years back. And this is really demonstrated by the fact we've launched over 200 new features into Redshift over the past years. We've highlighted a few. We're happy to go into more details on subsequent slides. But knowing that your feedback in terms of how we can make Redshift better has been taken in, and we're constantly working on the next iterations of Redshift to reduce costs, to make it easier to manage, but ultimately to help you as our customer get more value from your data and to drive innovation. Here's a couple that I wanted to call out that are in more detail from the previous slide. And I think the biggest changes, particularly if you looked at Redshift a few years back, the biggest changes you'll see I'll highlight next. So the first is concurrency scaling. So with concurrency scaling, Redshift now can automatically shrink and grow the size of your cluster based upon the workload. But we don't just do it at the full cluster level. You can actually pin it to individual users or groups, which is then tied tightly to a feature we call automatic workload management with query priorities. So you might have an ETL user group that's loading their data, and they just need to make sure that their data load can happen during peak times. But at the same time, you might have business intelligence users that need to query the data. And so you can start off with these two basic groups, ETL group, BI group, and give them different priorities. We have up to 5 different priorities you can assign those users within those groups. But then you also have the ability to check a box and say, for example, with the BI group, enable them for concurrency scaling. So what will happen is the Redshift database automatically, with no interaction other than that checkbox you selected, will look at the actual usage of the database. And if I am doing a heavy data load that potentially could impact my reports or queries from the BI group, we'll simply grow the size of the cluster to accommodate those new users. And you're able to then look at by the second usage for that additional consumption. And concurrency scaling gives you up to 1 free hour a day for a cluster that's used with a 24-hour period. And because AWS billing is monthly, you effectively get 30 free hours a month of concurrency scaling, which can provide tremendous cost savings, but more importantly, deliver fast, consistent performance. And so this combination of concurrency scaling with automatic workload management really simplifies the administration of Redshift such that you can now scale to almost unlimited concurrent users and queries, which is a dramatic change from the columnar database architectures of the past. As well as we touched a little bit with the Redshift managed storage and the RA3 instance type that introduces full separation of compute and storage that allows you to price and configure workloads based upon the compute required, but detach that from storage. And so the combination of RA3 instance type with concurrency scaling is oftentimes where customers will start when they look at Redshift today. There's also been a few key features particularly relevant as we think about migrations around stored procedures. And so now Redshift has support for PL SQL stored procedures, which oftentimes can help in migrations from legacy systems like Oracle or Netezza, where perhaps these stored procedures were heavily utilized. Some basics in terms of pause resume, particularly relevant for clusters that aren't leveraged 24/7. And now being able to pause and resume workloads is another key feature that Redshift can deliver on. Lots more details behind each of these features available on our What's New, but more importantly, we'd love to hear how your feedback in terms of how you can leverage these within your cluster and your architecture as you get started with Redshift. So we talked a little bit about the RA3 nodes, but just wanted to double click for a minute on what it actually delivers. And so today RA3 comes in 2 instance sizes, the 4XL and the 16XL, that's really designed to give you this best separation of compute and storage without having to compromise on performance. And so because we pay and provision compute and storage separately, it really is built upon this high bandwidth networking that's available from AWS, as well as our innovation and features that help deliver this from a Redshift perspective. And so if you're getting started with a migration project, we recommend you start with the RA3 instance type and be able to size your workload based upon the compute, and knowing that you have the Redshift managed storage underneath that to be able to manage the storage of your database without having to pre-provision or think too much about the size of data I need to load. Here's just a great customer quote from Duolingo in terms of their experience with RA3. That really delivers upon the ease, if you're using Redshift today, how easy it is to move to RA3. But more importantly, if you're getting started, how you could take advantage of the separation of compute and storage that RA3 instance type can deliver. And evolving this a bit, so thinking about these data warehouse concepts like shared nothing, MPP, columnar database, all these sort of terms and lingo around data warehousing. But really, what we want to think about is how we disaggregate the compute and storage, how I can still take advantage of shared nothing architecture, but not have to do extensive planning in terms of the compute or planning for peak. And that's really what cloud architectures and cloud data warehouses promise to deliver, that now Amazon Redshift can help you achieve with the new RA3 instance type. But this next generation architecture, so moving away even from shared nothing components that is traditional and on-premise data warehouses to a cloud data warehouse backed with Redshift managed storage for the best performance and analytics to be able to deliver that insight. And so building upon this concept of separating compute and storage, we've really been thinking hard from an engineering perspective how we can better deliver this. And one of the concepts that oftentimes gets missed when you separate compute and storage is the I/O bandwidth needed, right? So if I have to move a data block from Amazon S3 to EC2, for instance, to do an operation, oftentimes at scale that can become a bottleneck. And so to help solve this, in preview today, we have a feature called Aqua, or Advanced Query Acceleration. There's no additional charge or configuration required for Aqua. It's simply part of Redshift Managed Storage. We're working in preview today, hopefully general available soon. But once Aqua is available in all regions, you'll be able to get the best performance in the world of separating compute and storage by essentially operating the database attributes directly in storage itself. And in testing, we can see anywhere from 3x to 5x better query performance, all by leveraging the advanced engineering that AWS can deliver in terms of query acceleration, in terms of being able to leverage high-speed bandwidth networks, but without having to think about that from an administration perspective. You simply can leverage Redshift Managed Storage, and once available, Aqua will help give even better performance for your workloads. So having talked a little bit about Redshift, let's cover a little bit about how we can accelerate our data warehouse migration. So the first, if I have an on-premise data warehouse today and I'm looking to migrate, you should know there's a tremendous amount of experience AWS has to be able to help you with this migration journey. And this really starts with some automation and tooling we've been working on called Schema Conversion Tool, as well as the Database Migration Service. So Schema Conversion Tool can simply do an evaluation of your on-premise system and come back with a report in terms of which objects can automatically migrate, which objects might need some manual help in terms of migration, and then actually create the target schema on Redshift and do the conversion. And so oftentimes Schema Conversion Tool becomes the starting point for customers when they're migrating their data warehouse. Then also tightly coupled to this now is the Database Migration Service. And so what DMS, oftentimes referred to in our acronym DMS, can provide is really the ability to also move the data. So Schema Conversion Tool moves the schema, converts the schema, can do a one-time data load using our extractors. But then if I need to have a period of time where I have, let's say, my Oracle database and my Redshift database running at the same time, Database Migration Service can help, with that synchronization of that data. And so this used in combination with our consulting partners or AWS professional services can really help accelerate the migration to a cloud-native data warehouse like Redshift. And so thinking more about Schema Conversion Tool and what the value it can provide, now we had a quick overview. And it's important, so Schema Conversion Tool is a free download. You can simply download it. We always recommend you pull the latest version as we're iterating on new features. And it provides this assessment report. The assessment report can then help guide in terms of scoping of the effort to migrate to Redshift, but also provides that automation in terms of converting objects, converting SQL scripts, converting structured query language or PL, procedural language, into Redshift native, but importantly leveraging the feature of the extractors to actually physically move the data. And so this oftentimes becomes an important component when migrating my data warehouse is how do I get my data to Redshift or to Amazon S3. And so knowing that I can target not just S3, but also leveraging external storage to be able to physically mail, let's say, a Snowball device to AWS to be able to migrate bulk data oftentimes becomes a key feature for leveraging SCT. And we talked a little bit about the extractors, and here's the databases that we support for the extractors to be able to unload your data and be able to move quickly to AWS for that migration. And so once we've migrated the schema, the table, the initial data load, knowing that DMS is available to be able to help synchronize that data becomes an important concept. And so for the data sources that DMS supports, oftentimes we can then synchronize the data as I move my bulk data and then keep the changes as I'm testing or validating those sources can become an important factor for migrating my data warehouse. So here's a couple tips that we have when you're thinking about migrating to Redshift. So thinking about if I have a system like Oracle, for instance, or SQL Server as two examples, or Postgres that are row databases. And so some of the terminology that we talked about earlier, so Redshift is a columnar database. And there's different kind of constructs that can be thought about in terms of denormalizing my tables, right? We've done a lot of work in schema conversion tool to kind of help with this conversion, but it's understanding some of the data modeling techniques to be able to get the best performance from a columnar database can become important, particularly when contrasting a row database to a column database like Redshift. But then also thinking about, SMP or symmetrical multiprocessing data warehouses, of which Teradata could be an example, and some of the join aggregates that perhaps you're using to get best performance from Redshift, and how that translates to the distribution keys or sort keys within Redshift. You don't have to overthink this when migrating. Oftentimes, Redshift is so easy to get started. You can simply take the defaults, like the automatic distribution style in Redshift, and then leverage the advisor in the Redshift console to help get recommendations as I'm iterating to get the best performance. But coming into a migration, kind of understanding some of these core concepts can help accelerate it as well. And then also just knowing that Redshift now has stored procedures. In fact, it's been out for about a year now. They can really help in those migrations, particularly where I have a lot of logic built into my data warehouse and how I can migrate that without having to rework that. And some of these key differences in terms of Redshift being a columnar database, in terms of the basic constructs of sort keys, distribution keys that are backed by automation and the Redshift advisor to help along that journey of getting the best performance, and then stored procedures to help with that migration are key considerations when thinking about the total value and project timeline to get the value from Redshift. But beyond just the tooling and the automation, the features, there's a large ecosystem of partners that are ready to help you with this migration journey as well. A few of them are listed here. We also have a link to our migration partners. And it's not just that these are partners of AWS, but these are partners that have deep experience in modernizing your data architecture in specific certifications and experience working with Amazon Redshift to kind of help provide that assurance in terms of being successful on your project. There's also a number of ISV partners, and so I mentioned earlier, thinking about data loading, that oftentimes when I move from on-premise data warehouse to Redshift, I want to be able to leverage the investments I have in my data transformation tool, my business intelligence tool. A common pattern in migrating to Redshift is let's keep our reports the same, but simply change out the on-premise data warehouse for a cloud data warehouse like Redshift without impacting the business users. And so knowing that we work closely with a lot of our business intelligence partners like Tableau, for instance, can really help provide that assurance to minimize that change or disruption. The same for data transformation with partnerships with Matillion and Informatica and Talon, just to name a few. As well as when I'm looking at a new data warehouse, like what's the latest in terms of third-party ISVs through the Amazon or AWS marketplace that can help accelerate that journey, knowing that we've done joint engineering work and assurance in terms of being able to get started quickly, but also knowledge and assurance that we've done the optimizations to make this journey easier. And then beyond the consulting partners, migration partners, knowing that there's a broad set of service partners as well to kind of provide the assurance when I'm not just thinking about migration, but really what's the next iteration of a modern data architecture built upon AWS to help unlock the value from all your data. So in terms of some next steps we'll get into and how I can keep learning, and one of the things I've learned in my 7 years at AWS is that our services keep evolving, features within the service keep evolving, and knowing that there's a few key resources on how to keep up to date with what's the latest. As we provided some links here, we'll provide the links as well, but just given the pace of change in the analytics market, and particularly with AWS and our customers, just no understanding like the change and being able to understand where I can go to see the latest about Redshift. Then importantly, knowing that there's a lot of great information stored on the AWS Big Data blog that really provides how customers can apply a lot of the services and features to their use cases can really be a great collaboration point in terms of learning. There's also a set of AWS labs and GitHub locations to be able to provide best practices, tips and tricks. If there's tuning scripts that we've done, diagnosing scripts, we really consolidate that in these locations to be able to help build a community around Redshift, best practices, and what's worked to be able to have that collaboration as well. Thinking about training and certification, so be able to build up your skills. There's a number of online and in-person training offerings that AWS offers to really help accelerate the journey to AWS and getting the most value from your cloud data warehouse. And finally, let's talk a little about next steps. And so if you're already using Redshift, we ask that you reach out to your account team and think about, get a briefing from us on the latest features, get an understanding like how we can better solve your next use case or expand, my use cases with services such as Amazon RA3 or Redshift RA3 to be able to separate compute and storage. And really thinking about what's new given this constant changing environment. If you're just getting started with Redshift today, we've got a lot of resources in terms of getting started guides, accelerated proof of concept plans to be able to simply not just take generic data sets, but your own data set and quickly load it into Redshift. And a lot of momentum in terms of our customer blogs to provide some of those tips and tricks around getting started with Redshift quickly. Having said that, I want to thank you for attending today's session. I hope you found it valuable on how you can migrate your legacy data warehouse to Amazon Redshift. But more importantly, embrace the concepts of Lakehouse and breaking down the barriers of data warehouse and data lake by evolving the cloud data warehouse to separate compute and storage and really being able to deliver fast, consistent performance for analytic workloads. But more importantly, how I can make innovation to be a core concept of my analytic infrastructure, all powered by AWS and Amazon Redshift. So thanks for attending today's session, and I look forward to talking to you soon.